Welcome to 9.5, Inequalities in Two Variables. So today we're just going to look at one inequality to graph, all right? So one thing we have to remember about a solution set of an inequality is that in two variables, the set of all ordered pairs with real coordinates that satisfy the inequality. So we're going to be thinking about shading. Okay, so the graph of the inequality is the graph of the solution set. So one extra thing or two extra things we have to think about when we're graphing inequalities is we need to think about dashed versus shaded, dashed versus solid boundaries. Okay. And shading. All right, the shading is where the solution set lies. So we're going to look at some linear inequalities, we're going to look at quadratics, we're going to look at circle inequalities, and we are going to look at log and exponential inequalities. So let's get started with linear inequalities first. So this first example, 2x minus 3y is less than 6. So this is in standard form, so all we need to do is plot the intercepts. So you can make a table of values. When x is 0, what's y? When y is 0, what's x? Now, pay close attention to the inequality symbol. It's strictly less than. So does that mean dashed or solid boundary? Hopefully you remember that means a dashed boundary. I want you to go ahead and graph this inequality and see if you can figure out where you're going to shade. When you're done, check back. Okay, hopefully you were able to get your x and y intercept. My y-intercept is 0, negative 2, so we plotted that. My y-intercept is 3, 0, so we plotted that. Because it's strictly less than, we're going to have a dashed boundary. And now we have to determine where to shade. So I like to choose the point 0, 0 if it is not on my boundary line. So when I plug 0, 0 in, 0 for x, 0 for y, I end up with 0 is less than 6. Which is a true statement. So I'm going to shade in the direction of this point according to my line. So I'm going to shade up here, and there is our solution set for this inequality. I could pick any ordered pair within this shaded region and it would satisfy our inequality. Next, I want you to try example B. Y is greater than or equal to negative 3x plus 7. So this is in slope-intercept form. So I identified our y-intercept is 0, 7. Our slope is negative 3. Go ahead, graph this inequality. Think about dashed versus shaded lines, and then think about where you're going to shade. Check back when you're done. So I plotted our y-intercept of 0, 7. I used our slope of negative 3 to go down 3 over 1, down 3 over 1. I have a solid boundary because it's greater than or equal to. I tested the point 0, 0. When I plug 0 in for y and 0 in for x, I get 0 is greater than or equal to 7. This is false. So since it's false, I then have to shade in the opposite direction of where that point is. So I'm going to shade to the right of this line. And again, any solution, any ordered pair in this solution or in this shaded region is a solution to my inequality. Now we're going to get into some nonlinear inequalities. So we're going to look at quadratics, we're going to look at circles, we're going to look at logs and exponentials. So hopefully we can recognize this is a quadratic. All right, y is less than or equal to x squared plus 2x minus 3. This is not in our vertex form. This is in our standard form. So we need to find our vertex. So hopefully you can remember that to get the x value of our vertex, we do opposite of b over 2a. So plugging into that, opposite of b is negative 2 over 2 times our a value is 1. So when we clean that up, we get negative 1. To get the y value of our vertex, we simply plug negative 1 into our x value and we solve for y, not worrying about the inequality aspect. When you do this correctly, you should get y to be negative 4. Please verify this. So now what we do is we put our vertex smack dab in the middle of our table and we choose some points that surround it for our x values. So since x is negative 1 for our vertex, there's our vertex. I'm going to choose values that surround it, 0, 1, and -2, -3. When we plug 0 in, this is a nice easy point. When x goes to 0, we're left with y being -3. Using points of symmetry, these two values of x are the same distance away from our vertex, so I know when I plug -2 in, I also get -3 for my y. I can plug 1 in for x, 1 squared plus 2 times 1 minus 3, I would get 0. Again, using points of symmetry, I know that -3 is the same distance away from -1 as 1 is, so my y value there will also be 0. We can go ahead and plot those 5 points. I know I'm going to have a solid quadratic, a solid parabola, because it's less than or equal to. Now we have to figure out where we're going to shade. So how did I determine that we're shading on the outside? Well, I can still test the point 0, 0 because it's not on my parabola. So when I test 0, 0, I get 0 is less than or equal to -3, which is not true. So since it's not true on the inside of my parabola, I then shade on the outside. Now we're going to look at a circle. So hopefully you can remember or recognize that this is an inequality for a circle. If we change that to an equation or an equal sign, we'd have an equation. If we have x plus 1 squared plus y minus 2 squared is greater than 9. Remember, the standard form of a circle is going to be x minus h squared, I'll plug in the h, plus y minus k squared equals r squared. And our h and k is our center. All right, and our radius is strictly r. All right, so in this case, we need to identify our center and our radius. Our center is going to be -1, 2. All right, hk. Our radius is going to be the square root of 9, and that's where we got 3 from. So the first thing we do is we plot our center point, which is -1, 2. I now use my radius of 3 to count up 3, down 3, right 3, and left 3 from my center. Now, why is it a dashed circle? Because it's strictly greater than 9. So we go ahead and we have our dashed circle. Okay, now how do we figure out where to test? Well, with a circle, there's a nice point to always use as a testing point, and that's our center. Our center will never be on our circle, okay? So if I test -1, 2, the nice thing about that is it makes this portion go to 0, so -1 plus 1, that's 0. If I plug 2 in for y, this goes to 0. So we are ending up with 0 is greater than 9, which hopefully we recognize is false. So since it's false on the inside of my circle, we're going to shade on the outside. Now we're going to get into exponential inequalities. So we treat these just like exponential equations. We create our table of values. Remember, I'm going to choose the value of x that makes our power 0. So if I set x plus 2 equal to 0, I get x equals -2, and that's the value that goes smack dab in the middle of my table. Now I'm going to choose x values that surround it, and I'm going to plug those x values into my equation, thinking of it as an equation. So when we do, when x is -2, we get y to be 1. When x is -1, we get y to be 3. When x is 0, we get y to be 9. And when x is -3, we get 1/3, -4, 1/9. So we go ahead and we plot those. Okay, now notice we still have a horizontal asymptote here. And our horizontal asymptote is y equals 0. We still have to make sure we plot this. Okay, so we've got that right here plotted nicely. Okay, all right, so again, I've got a solid graph because it's greater than or equal to. Now, we have our horizontal asymptote. We have to figure out where we're going to shade. Now I can test 0, 0 because it is not on my boundary, even though it is on my horizontal asymptote. That's okay. I'm plugging it into here. So when I test 0, 0, I plug 0 in for y. That's where the 0 comes in from. I plug 0 in for x, and I get 9. 0 greater than or equal to 9, that's false. So where are we going to shade? Well, since 0, 0 is outside of this exponential, we're going to shade on the inside. Next, we're going to look at a log inequality. First thing I want you to do is I want you to change this to a greater than. Yours might say y is less than log base 2 of x. Change it to y is greater than log base 2 of x. So remember, when we're graphing log functions, the first thing we do is we change it to exponential. So 2 to the y equals x. Let's just treat it like an equation for now. So now I take my y value, or my power, and I set that equal to 0, and that's what I get for my y value. All right, now we're plugging in for y, so I'm going to choose values that surround it, and when I do, I will get these x values in return. Okay, now notice this time we have a vertical asymptote of x equals 0, and again, you better plot that. Okay? All right, so now we plot those points, and notice this time it's going to be a dashed curve because it's strictly greater than. So now I have to pick a point, okay? Now this one's a little trickier because we're dealing with logs. So I'm going to pick a point that gives me an x value that has the same base as my log. So I choose the point 2, 0, okay? So I plug 0 in for y, I plug 2 in for x. Make sure you change those to greater than. I forgot to, so I apologize. So when we plug those in, we get 0 is greater than log base 2 of 2. Well, log base 2 of 2 is 1. Is 0 greater than 1? No, again, this is a false statement. So where are we going to shade this time? Well, since it's a false statement and that 2, 0 is inside, we're going to shade on the outside. However, because we have this vertical asymptote, we have to make sure that we are to the right of that vertical asymptote and outside of our graph. So it'll look something like that. If you have any questions, let me know.